Hi, and welcome to part 3 of factorization. As promised, today we'll be doing the factorizing by grouping. Now, before we get started, I just want to do a quick revision on something that may or may have not been too obvious. But by now, if I had asked you to factorize 2m minus pm, the concept of pulling out something, like I've said in the last two videos, is that when you pull out something, you already divided. But a question simple like this. You'll notice that the m and the m are the same. There's an m here and there's an m here, and they're perfectly the same. So if I had to ask you to pull out an item, the first thing that should come to mind is I'm going to pull out the m. So the division, you could do it in your head, or you can just pretend that you're moving this m outside and this m outside, but although you're moving two m's outside, you're only going to write it once. So my answer will look something like this: 2 minus p. So I pull out the m from both items, and the reason is the m is the same in both items. Now, a question like this easy, may not come in an exam. A question like this may not come in an exam also. What's the same between these two items? X. So immediately, you can just pull out the x and you'll be left with minus 3 plus k. Now the reason you pulled out the x again is because the x and the x are the same in both items. Question 3. Yes, you're seeing correct. It's a smiley face. What's the most obvious thing to pull out here? Won't it be the smiley face? The reason is the smiley face and the smiley face are the same. So, although this question looks weird, it has a similar it's very similar to question 2 and question 1. In these two, the m were the same, so you pull them out. In these two, the x were the same, so you pull the x out. And in these two, smiley face is a common one. So if I were to factorize this, I would get smiley face outside. And what would I be left with in the brackets? Minus 4 plus m. Now look at number 4. Number 4 looks more complicated than the rest. However, if you notice, there's a 2x plus 3 here and there's a 2x plus 3. There are two same items here. Now, if this was a smiley face and if this was a smiley face, you would pull out the smiley face. Now, instead of a smiley face, we just have 2x plus 3. And a key thing to remember is when you pull out something, you only write it once. So if I were to factorize this, I would pull out the 2x plus 3, but I'll make sure and put that in brackets. If I pull out the 2x plus 3 from here, I would be left with the 4. So I'll be left with the 4. And if I were to pull out the 2x plus 3 from here, I would be left with the f. And that's it. We factorized 4 items, and we did it easily by pulling out something that was similar to both items. Now I'm going to get started on factorization by grouping. Factorization by grouping is going to follow this very, very, very simple concept. So let me put my first question that will require factorization by grouping. Alright, so let's get started. So we have my first question is x squared plus 2x plus xy plus 2y. Now, in an exam factorization by grouping, usually you need it when there are 4 items. And in a lot of exams, this is a standard question. They will give you 4 items. Now, whenever you see the 4 items, try not to factorize the entire expression. Instead, I want you to group it in twos. So I'm going to pay attention to the first 2 items And then I'm going to pay attention to the next two items. So I'm going to factorize this. And when I'm finished factorizing this, I will factorize the other two. So let's pay attention to this guy here. What's similar between both of them? Isn't x squared the same thing as xx? He has an x to spare and he has an x to spare. So because both of them are the same, I think I should pull out x. If I pull out x from here, if I pull out one of the x's, I'll be left with x alone. And if I pull out x from here, I'll be left with 2. So let's factorize this one here. What's the same between the two? Between the two, this one has a y and this one has a y. So let's pull out the y because that's what's similar between both of them. However, I'm going to do something slightly wrong so you'll get an idea of what not to do. I'm going to pull out y. Now, if I pull out y, I will be left with x here and I'll be left with 2 here. The problem is, if I just pull out y and I leave nothing in between here, it will be taken as a multiply. We were pulling out positive y. So when you pull out the y, make sure and write the positive because we don't want to misinterpret this as a multiply. So signs are very important. Usually when you are in maths, if something is positive, I always tell my students, I know if you write nothing here, it's automatically positive. I would prefer if you write the positive. It will reduce the amount of errors that you're making in a complicated question. So make sure if you pull out positive y, you write the positive. If you pull out negative y, if you happen to have to do that, make sure and write the negative side. So, you all notice something here? Don't I have x plus 2 here? Don't I also have x plus 2 here? And these two items are exactly the same. So this comes like a smiley face now, and this comes like a smiley face. Let's pull out the x plus 2. If we pull out the x plus 2, what will be left here? X. And if I pull out the x plus 2 here, I'll be left with y. Notice that I'm pulling out the x plus 2 from here and the x plus 2 from here, but I'm only going to write it once. This is the final answer. And if you were to expand these brackets and simplify it, you would get the original expression. So let's do another example. This takes a little while to sink in. So let's do another example. Right. So let's see. What do we have on the list here? We have 5n cubed minus 10n squared plus 3n minus 6. Alright. This is probably the first time we're seeing an n cubed. N squared means n multiplied by n. N cubed just means n by a third n. So if you want, you can imagine it as 5n minus 10n squared, that's an n and an n, plus 3n minus 6. Right. Here's what we're going to do. It's 4 items, 1, 2, 3, 4. Usually in a case like this, it's not a good idea to try to factorize all 4. Break it up into groups of 2. What is similar between the first two? 5 could go into 5 and 5 can also go into 10. So I think I'm going to pull out 5 for sure. He has 3n and he has 2n. So he has 2n to spare. We can pull out 2n here, and he has more than 2n. So we can pull out 2n from here. So we are going to pull out 5 and an n. Now 2n, so we're pulling out 5 and n. N by n is n squared. So we're pulling out 5n squared. If we pull out the 5 and 2 n's from here, we'll just be left with n. And if we pull out 5 from 10, we're already dividing by the 10 by the 5, we will get 2. And if we pull out the 2 n's, well, there will be no more n's left. Make this brackets a little smaller. 5 and 2 n's, 2 and 2 n's, 4 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 and 2 n's, what can we pull out from these two? Well, 3 can go into 3, and I know 3 can go into 6. There's an n here, but there's no n by the 6, so it's not a good idea to pull out any of the n's. So I think I'm going to pull out positive 3. I made sure and write my positive. Pull out the n from, pull out the 3 from here, you'll be left with the n. Pull out 3 from 6. 6 divided by 3 is 2. You notice that this and this look exactly the same. Smiley face, smiley face. Pull that out, but only write it once. If we pull that out, we will be left with 5n squared, and we'll be left with 3. Right. Let's try another example. I want one a harder one. Let's try a harder one. Alright. So let's try 2a x squared plus b x squared minus 2ay squared minus by squared. Right? This is a little bit scarier than the other two. The other three we did. So, provided that I have written this correct on the board, we should be able to work it out. It's 4 items again. 1, 2, 3, 4. Let's pay attention to the first two. Both of them seem to have an x squared in them. They don't seem to have anything else similar. So I suggest we pull out the x squareds. So if we pull out the x squareds, we'll be left with 2a here, and we'll be left with b here. So we pull out the x squareds. We will be left with 2a plus b. What's similar between these two? The y squareds. That's the only similarity between those two. So I suggest we pull out the positive y squared. If we do this, we will be left with minus 2a, because we're only pulling out the y squared, and we'll be left with minus b. We have a slight problem. The two items in the brackets are not exactly the same. They look similar, 2a and b, 2a and b, but you notice these have positives and these have negatives. They are not exactly the same. For us to extract them, they must be exactly the same. So remember, I think it was one video ago, I told you that you don't always have to pull out a positive. Sometimes you will be forced to pull out a negative, and this is one of those instances. Instead of pulling out positive y squared, we should pull out minus y squared. When we pull out the negative version of what we just did, you don't have to go back and do your work here. Everything in the brackets just become the opposite. Negative will become positive, and a negative will become positive. Now they look exactly the same. So this and this are the same, so we pull them out and only write it once. So 2a plus b, and we will be left with x squared minus y squared. And once again, this is the final answer, and if we were to multiply out the brackets and simplify it, you would get back the original answer. The original question, sorry. Alright, so that's factorization by grouping. In my next video, I will be showing you how to factorize a quadratic equation. Now bear in mind, to factorize a quadratic, you have to be able to understand factorization by grouping. Because to factorize a quadratic has 3 items, but when you're doing the question, it will boil down to 4 items, or boil up to 4 items, since it has more items now. Alright, but whatever. The point is, make sure you understand factorization by grouping first, before you watch the next video, which is factorization of quadratics. Alright, so once again, don't forget to check the website below for more details, and once again, my normal speech is have a good day or a good night. So have a good day, have a good night.